So to start with, here is a tableau. We have the 5 variables A, C, S1, S2 and S3. Let's write down the 3 constraints. The constraint number 1, shown as row 1, has 12A plus 6C plus S1 is equal to 20,400. The constraint number 2 can be read as 9A plus 15C plus S2 is equal to 25,200. And constraint number 3, just like we had in the equation form, is 6A plus 6C plus S3 is equal to 12,000. So in the tableau right now, we have the 3 constraints specified. Let's now include the basic variables on our table. The 3 basic variables are S1, S2 and S3. The objective function coefficients of these basic variables was 0, 0, 0, which we will specify here on our tableau. Now, the only thing missing here is the objective function. So we will also then bring in the objective function. The objective function was Z is equal to 50A plus 40C plus S1, 0S1 rather, plus 0S2 plus 0S3. Now, we can convert this to an equation by bringing all the variables to the left-hand side. So that is essentially Z minus 50A minus 40C minus 0S1 minus 0S2 minus 0S3, and then we equate it to 0. And this is what then we transfer onto the simplex tableau. So that is then row 0, which reads as Z minus 50A minus 40C plus 0S1 plus 0S2 plus 0S3 is equal to 0. We should note that the columns under the basic variables, which is S1, S2, S3, are identity columns. The current values of the basic variables is equal to the right-hand side, and we can easily read that off because the variables A and C are 0 and the columns for the basic variables are identities. The non-basic variables, the A and C, are of course taking a value of 0. Now, this was the first corner point that we started from. The question is, can we move to another corner point which is better than this one? Well, yes, we said we can increase the value of A or C, and both of us will take us to a higher objective function value. Let's say we decide to increase the value of A, since it will improve the objective function by 50 per unit, compared to C, which will only improve it by 40 per unit. Then the tableau looks like this. So on the tableau then, A becomes the entering variable. Now once A becomes the entering variable, essentially it will become a basic variable. Remember, we had to have only 3 basic variables. Therefore, if A becomes a basic variable, one of the S1, S2, S3 will have to leave the basis and become non-basic. The question is, which one of these 3 variables, currently basic variables, should leave the solution and become non-basic? And that is the step where we will decide on the leaving variable. Let's try to intuitively see this on the graph. So we are moving from the corner point B, increasing the value of all pro footballs. The question is, how much can we increase this value by? Of course, we need to remain feasible when we are doing so. So if we are increasing the value of A, the first corner point that we are moving in the direction of the x-axis, and the first corner point we will come to is the corner point C, where the constraint number 1 becomes binding, which means then that constraint number 1 then has no slack, and at that point S1 becomes 0. We could go further and come to corner point F, where constraint number 3 becomes binding. That means S3 becomes 0. There is no slack in constraint number 3. And if we go yet further, we will come to the point G, where constraint number 2 becomes binding. That means the slack in constraint 2 becomes 0. That is, S2 becomes 0. However, both F and G are infeasible corner points. So therefore, the best we can do is move up till the corner point C. After that, there is no feasible region left for us to move into. So therefore, on the tableau, the leaving variable becomes S1. A is entering, S2 is leaving. So how will we do this on the tableau? We will have no access to the graph. We'll have to do this algebraically. Look at the constraint number 1. As the value of A increases, so constraint number 1 reads as 12A plus 6C plus S1 is equal to 20,400. So as the value of A increases from 0, the value of S1 will have to come down. How much will the value of S1 have to come down by? Well, each unit increase in A will decrease the value of S1 by 12. And therefore, the maximum that we can go, or the maximum limit we can go up to, would be 20,412 divided by 12. That is, the maximum value we can give to the variable A is 1700, because at that point, S1 will become 0. And then if we go any further, S1 will start becoming negative, which we cannot have. Similarly, from constraint number 2, if we increase the value of A, then the furthest we can increase it by would be 25,200 by 9, which is 2,800. And then similarly, if we look at constraint number 3, the maximum that A could become would be 12,000 by 6. So that is 2,000. And therefore, we will have to pick the minimum of these so that we stay at the corner point C on the graph. The other 2 points are the F and the G, the infeasible corner points. And that's why then this is called the minimum ratio rule. Essentially, we are taking a ratio. The column under A is telling us how S1, S2, S3 will change. The current basic variable values will change when A comes in. And therefore, we can calculate the minimum ratio of the right-hand side with the entries in the column under A to decide so as to what has to leave. So amongst these, then, S1 will leave. Now, once we've decided the entering variable and the leaving variable, we will have to move to that new corner point C that we saw on the graph. So we will have to move to the new corner point solution, and we'll have to do this algebraically. Let's see how to do that. Note that A is now a basic variable, and the basic variables are supposed to have identity columns under them. So therefore, we will have to make the column of A an identity column. How would we do that? We will do this by using the elementary, what are called elementary row operations, which means that we can do these operations on any one of the rows that we have on our tableau. Multiply a row with any number. We can also add a multiple of any row to any other row that we have. And the reason we can use these operations is because they do not change the solution to a system of equations that we have.